So you're going to be tested on calculating areas under graphs. The problem is that not every problem in physics involves doing 1/2 base times height of the area under a rectangle. In fact, the majority of problems you solve in physics have nothing to do with calculating areas under curves directly. And so we actually need kind of a heavier arsenal of things to use in solving problems. And that's where the three equations of kinematics that we teach in physics sort of come in. And these are for uniform acceleration, which is what we're studying. So first, let's just start by writing these equations down. So we have x equals 1/2 at squared plus v naught t plus x naught. We have v squared equals v naught squared plus 2a delta x, which means x time minus x initial. And we have v equals at plus v naught. Excellent. Now, these are three equations, and really what you're going to do is memorize them. Okay, you will not be given these on the exam, so I'm just going to be clear. Memorize. So, when you come to the exam and you say, Mr. Dula, I don't have the equations memorized, I will go to week 5, lecture 2 or lecture 3, whichever one I keep this in, and then you're going to take a look and say, oh, you did say memorize. Very good. Now, let's go on and solve this difficult problem here, which is number 3. And the thing is, graphing's not going to work for this one, because this is not a velocity, this is a final position. Okay? So let's actually draw a picture of what's going on. We have a bear, that's my bear, and we have a beehive, it's a beehive. So your diagram should be these completely vapid, soulless drawings that just convey only scientific information. So we don't want to encourage creativity. Okay, you should sort of feel like a drone just being forced to slave away at physics problems. So we have an initial position and an initial velocity, a final position and a final velocity. And let's label those. So x naught, I'm going to give you a hint. If they don't tell you where it starts, just assume that the initial velocity is 0. And for the v naught, it also starts at 0. And then we go to an x final, which is 16 meters. And our final velocity, we actually don't know what that is. And of course, we have an acceleration of 2 meters per second squared. So we've labeled all these letters. Notice we don't know the time either. Okay. So here's the trick I'm going to tell you. Okay. Physics professors who've been doing physics for a long time are really good at saying, oh yeah, you know which formula you want to use? You want to use this one. And then they'll just go ahead and use it. Actually, I don't know if you want to use that one. Maybe you don't want to use that one. Maybe you want to use number 2. Or perhaps number 3. But they have this intuition about picking formulas. We are not going to ever pick a formula. What we're going to do is this. We're going to plug every single one of these numbers into every single formula. And then we're going to solve each one of those formulas. And the question we will ask is this the answer? Well, if not, move to the next one. Is this the answer? And we keep going until we've used up all 3 of the formulas. All right? So here we go. Let's actually do formula number 1, and I'll actually do it right here. So we have x equals 1/2 at squared plus v naught t plus x naught. Like that. Let's go ahead and plug in our numbers. So we have 16 equals 1/2 times 2 times t squared plus 0 plus 0. So it looks like here, I'm not going to be getting the how fast the snout will be going. Move on to the next formula. Okay. So we have v squared equals v naught squared plus 2a delta x. Plug in our numbers. So we have v squared is our unknown. We start off at rest, plus 2 times 2 for the acceleration, times this x final minus 0. Wow. And do we have a value for x final? Well, when we look, we realize, oh, hey, wait a second. We've actually been given a value. So we can go ahead and we can actually then go ahead and check that. So when we put that in there, that's actually 16. Good for us. Okay. Then we write down the third equation, and we have v equals at plus v naught. Now, I'm sure most of you are looking at this saying, you know what, Mr. Abdullah, I get it. It's equation number 2. There's the answer. Stop talking and just solve it. Okay. The point is, I want you to be better than good at these. Okay. And that means you need to be fluent with all 3 equations. And I want these memorized. So to that end, you will write out every single equation for every single problem, plugging in every single number and only solving after the numbers have been substituted. Okay. Then here, for number 3, we're going to have v equals 2 times t plus 0. So clearly this formula is useless. So when we solve here for time, you guys can do the algebra. You're going to get that t is 4 seconds. Yay. And when we solve for the v squared here, we're going to get v is 8 meters per second. Okay. So this is number 7, and let's go ahead and solve it. So we have a go starts with a rock slide, the rocks crash down 1,200 meters. So let's just go ahead and talk about what's happening here. So we have this, the rocks start here and they go here. So we start from x naught equals 0 and they go to 100 meters. It starts at, and now we have a time is 5 seconds here. We have a v naught equal to 0. We don't know the acceleration. We don't know the final velocity. So let's go ahead and use our equations to solve that. So we have x equals 1/2 at squared plus v naught t plus x naught. And in fact, what I'm going to do is actually move this up here. And then we're going to also have v squared equals v naught squared plus 2a delta x. And finally, we're going to have v equals at plus v naught. Let's go ahead and plug in our numbers. So we have 100 equals 1/2 times a times 25 plus v naught t, which is 0, plus 0. So for this one, it actually looks like we have 200 divided by 25, and our acceleration ends up being 8 meters per second squared is our acceleration. So there we actually did get the answer right. So that's sort of how we're going to do this. We kind of run through these equations one at a time and plug in the numbers as far as we can go. And in that case, we get lucky. If not, we just go on to the next equation. So that's pretty much it for the problems. Remember, you're going to be doing part B in class for 8 using these 3 formulas here. So hope this helps. Have fun and good luck.